Okay, so we're looking at straight line graphs, and we're first going to understand the standard format. So this slightly weird looking y equals mx plus c equation. We're going to look at the gradient and the y-intercept and what they actually mean. And finally, we're going to do a couple of examples of parallel and perpendicular lines once we kind of understand what the gradient is telling us. And we're going to finish off with an exam style question. So let's first look at this this standard equation, y equals mx plus c. What does it mean? Why do we use it? Well, the easiest way to understand this is if we look at an example. And so if I, draw some random line, I'll do that. We're going to have a y-intercept, so we're going to intercept the y-axis at a certain point, because so this is equal to, I don't know, 1. And so in this case, c would be 1, right? It's literally where do we cross the y-axis? What's the value of y when we cross the axis? The gradient is a bit trickier. The gradient, if we were to actually look at what's going on in this equation, imagine if I increase x by 1, right? If I say I start at this point, say I start at this point here, right? I start at my intercept, and I increase x by 1, so I move along my x-axis. This is my x and my y-axis. If I move along 1 in the x direction, let's say m is equal to 2. What's going to happen to y if I increase x by 1? Well, if I increase x by 1, this whole thing is going to increase by 2, right? Because I'm timesing this increase of 1 by 2, because m is 2 in this case. And so what we end up seeing is, on my graph, my y is going to increase by 2. And so I move up by 2 spaces. And again, I can do the same thing again, right? I can move along 1 in the x-axis. And again, my equation tells me I have to move up in the y direction by 2. And so that's what m is, right? M is really, it's telling me how much do I move in my y direction, given that I move some distance in the x direction. And this is easiest to understand if we decide that the change in x, this is change in y over change in x. If we decide the change in x is just going to be 1, right? In this case, we've just said the change in x is 1 in both these cases. Well, all of a sudden, I basically end up with m is equal to the change in y. If we decide that we make the change in x equal to 1, right? Because anything divided by 1 is just itself. So that's my gradient, right? It really tells me how much do I move up or down by, and therefore how steep is my graph, right? You imagine, if we imagined instead of a gradient of 2, we had a gradient of 4. Well, all that's going to happen is rather than moving up by 2, I'll move up by 4. I'll move up to that point there, and we end up with a line that's not supposed to be wiggly, but it's slightly wiggly. We end up with a line that's much steeper than my original line. So that is gradient. Y-intercept, again, it's just where we intersect the y-axis. And so that's been taken care of. Let's now look at parallel and perpendicular lines. Well, parallel lines are very, very easy. Right? All we need to understand is, if I keep this same example that I had over here, this is going to have, just to finish this off, we've decided the gradient is 2 and the intercept is 1. So the equation for this would be y equals 2x because m is 2, plus 1 because c is 1. And so I'm just going to copy this out over here. This is my my equation for the line, 2x plus 1. And let's look at a parallel line. So a line that's going to run parallel to my original line. Well, because it's parallel, it's got to have the exact same gradient and same slope, right? Because if they're pointing in the same direction, they've got to have the exact same slope. And because gradient is literally the definition of the slope of the line, the gradient has to be the same. And so for this line, my gradient is 2, right? I'm going to say m is 2. We often use m for gradient. And for this line, again, I know my gradient has to equal the exact same thing. It has to be equal to 2. So slightly weird 2 there. There we go. Perpendicular lines are slightly trickier, but again, not too bad. And we'll stick with the same example. We might as well stick with the same example. So this is I'm actually just going to keep it to gradients for now. So I'm going to say just the gradient of this line is 2. And let's look at a perpendicular line. So I'm going to draw this in a new color. I could have a perpendicular line anywhere along this line. All that perpendicular means is we intercept at right angles. So that angle there between the two lines is 90 degrees. Well, what's the gradient of this intercept of this perpendicular line going to be? Well, I know that because my original line is pointing upwards, my new line has to point downwards, right? We can't have a 90-degree angle and have two lines both pointing upwards. It's never going to happen. So I know that my new gradient is going to be minus, and it's going to be minus some number. To understand what that number is, to understand what the magnitude of this gradient of this line is, it's probably easiest if we do another example. And so I'm gonna draw in a shallower line in this case. I'm gonna draw in a shallow line. Let's make it look like this. And again, we'll plot out the perpendicular line. So again, it doesn't really matter where on the line I draw my perpendicular line, as long as it's perpendicular. Well, what we're seeing is, this new line could have, say, a gradient of, well, we can work it out, right? We could say if we go along by 1 in the x-axis, how much do we go up by in the y-axis? Let's say we go up by a half. That looks about right. So my gradient is going to be a half. And so what I'm doing is, from my original line to my new line, I'm reducing my gradient, right? I'm making it shallower. Well, what's happening to the perpendicular lines? Well, originally, the perpendicular line was quite shallow, right? This is my original perpendicular line. And what we can see is, as we go from my first line to my second line, my perpendicular line is actually increasing in gradient. Right? It's getting steeper, isn't it? And so anything that's steeper has a much greater gradient. So what's happening is, as I'm reducing my original gradient, I'm increasing my perpendicular gradient. Well, the way that we represent that mathematically is we do 1 over the original gradient. And I'm actually going to label the new gradient of the perpendicular line MP. So we don't get confused. These are two separate M's. This is my original. I can call this MO. And this is MP. And so what we find is our new gradient of our perpendicular line is always going to be equal to the negative reciprocal, so minus 1 over the original gradient. And we can see in practice, if I reduce the value of my original gradient, if this goes down, what's going to happen to the overall fraction? If the denominator decreases, the overall fraction is going to increase. And that is parallel and perpendicular lines. So let's dive into a couple of exams style questions now. Hopefully this all makes sense. So we've got an exam style question. It says on the grid, draw the graph of y equals 3 minus 2x from minus 2 to 4. So this isn't in our standard equation format, right? We generally want y equals mx plus c. So what we can do is we can just swap these around. I can put my minus 2x first and my plus 3 second. And all of a sudden, we can see exactly what's going on here. So I know my gradient is going to be minus 2, and my y-intercept is going to be 3. And so I know my line has to pass through that point there on the graph, has to pass through y equals 3. And the gradient tells me that if I go along 1 in the x direction, I've got to go down by 2 in the y direction. So I get to that point there. Again, I go along 1 and I go down by 2. And I can keep doing this, but I don't need to draw on all the points. I can actually just jump straight in and draw a nice straight line, and I get that there. And we can see it intersects all my points. So we really just need 2 points. I could have actually skipped this point or skipped this point. It doesn't really matter. So that was our line. So as soon as we understand the gradient and the y-intercept, we can then draw our line. Let's do 1 or 2 more. So a straight line L is shown on the grid. Work out the equation of line L. Well, again, I know, I'm going to jump to more contrasting color. I know that the y-intercept is going to be 1, So C is going to be 1 in this case. And if I look at what's happening, if I go along 1 in the x direction, how much do I go up or down by in the y direction? Well, I know in this case, I've got to go up by 2 in the y direction. And so that tells me my gradient. And so if m is 2 and c is 1, I end up with y equals mx plus c. So m is going to be 2 and c is going to be 1. Right, last example, and then we'll call it a day. So the straight line L has equation y equals 2x minus 5. Find an equation for the straight line perpendicular to L, which passes through minus 2, 3. So in this case, I'm just going to draw out what's going on. So I think it's easier if we can visualize it. And 2x minus 5, well, I'm going to intercept at minus 5, and I'm going to have a gradient of 2x. So it's going to look something like that. That should really intercept there. And I want to work out the perpendicular line that passes through minus 2, 3. Well, if it's passing through minus 2, 3, it's going to pass through that point there, roughly there. And it's going to be perpendicular. So I can't draw today. So it's going to look something like that. That's going to be my perpendicular intercept. Well, I know that the gradient of my new line, my perpendicular line, is going to be equal to the negative reciprocal of the original gradient, minus 1 over the original gradient. Well, the original gradient, which I'll call MO, is going to be 2, so it's minus 1 over 2. And we're halfway there, right? We always need our line equation to be in this format, y equals mx plus c. And so I'm halfway there. I've got m, which is minus a half, but I don't have c yet. I need to find out what is c. How can I do that? Well, I've got a point on the line, right? I know the fact that my perpendicular line goes through minus 2, 3. It goes through this point here, minus 2, 3. And so I can use that to work out what c is. Because I know that if I put in x equals minus 2, these are my x and y coordinates. If I put in x equals minus 2 into my equation, the equation should always spit out 3 at the end of the day, because I know that y has to equal 3. And so I know that I should be able to get minus a half times minus 2 plus c to get 3. Well, minus a half times minus 2, the minuses cancel out. We've got a half times 2. That gives me 1. And so 1 plus c has to give me 3. Well, c, therefore, has to equal 2. And so we end up with y equals minus a half x plus 2. And that looks about right, doesn't it? Now, that point there is going to be roughly 2. And that is the end of our lesson.